What if I told you these aren't just quirks of biology, but hints of something far stranger, far more fundamental, happening right between your ears? We're talking about the mind-bending rules of quantum physics potentially playing out in the very core of your consciousness. Stick around, because we're about to explore a scientific frontier that sounds like fiction, but might just be the key to understanding the true power of the human mind. Now let's get one thing straight. Quantum physics is weird, really weird. At its heart lies a phenomenon so bizarre Einstein himself called it spooky action at a distance. It's called quantum entanglement. Imagine you have two special coins. You flip them and they land in separate sealed boxes. You open one box and see heads. Instantly, faster than light, you know the other coin must be tails, even if that box is on the moon. These coins are linked, entangled. Their fates are intertwined, no matter the distance. Think about that. Two particles, once connected, remain linked in a fundamental way. Measuring a property of one particle instantaneously influences the property of the other, regardless of separation. It defies our everyday logic of cause and effect happening locally. For decades, this spookiness was confined to the ultra-cold, ultra-controlled world of physics labs, dealing with subatomic particles. We saw it with photons, particles of light, recently even capturing images of this ghostly connection. It was fascinating, but surely, this delicate quantum dance couldn't happen in the warm, wet, messy environment of the human brain, right? Well, hold on to your neurons, because that's exactly where things get truly shocking. Neuroscientists peering into the living brain have stumbled upon evidence suggesting this exact quantum phenomenon might be happening within our own brain waves. This isn't just a fringe theory anymore. It's emerging from serious research, potentially rewriting the rulebook on how our brains process information, generate consciousness, and maybe even unlock hidden potentials. Picture this. Scientists at Trinity College, Dublin, armed with sophisticated MRI technology, weren't just looking for blood flow, the usual target. They adapted their techniques to look for something much more subtle, something that hinted at quantum processes. What they found, published in late 2022, was electrifying. They detected specific brain signals that exhibited characteristics uncannily similar to entangled quantum systems. Now here's the kicker, the part that sends shivers down your spine. These entanglement-like signals weren't just random noise. They correlated directly with moments when the study participants were consciously aware and engaged in cognitive tasks. When the participants drifted off to sleep, when consciousness seemingly faded, these specific signals vanished. It was as if the very presence of consciousness flickered these quantum connections into existence. Imagine that. It's like finding out your car engine doesn't just run on gasoline, but also gets a boost from tiny, invisible teleportation devices that only switch on when you're actually driving attentively. Could it be that the very act of being aware, of thinking, feeling, and making decisions, relies on harnessing this quantum magic, as the researchers hinted? If this connection between observed quantum-like signals and the state of consciousness holds up under further scrutiny, it's not just a small step. It's a quantum leap in understanding ourselves. It suggests that consciousness isn't just an emergent property of complex classical computation, but might be deeply rooted in the fundamental quantum nature of reality. Why is this potential quantum connection such a game changer? Think about what your brain does effortlessly every single second. It processes a torrent of sensory information, retrieves memories, makes complex judgments, learns new skills, navigates social interactions, generates creative ideas, all with incredible speed and efficiency, using only about as much power as a dim light bulb. Even the most powerful supercomputers, crunching numbers at blinding speeds, struggle to replicate the fluidity, adaptability, and nuanced understanding of the human mind. Why the discrepancy? Why are our biological brains so remarkably adept? According to Dr. Christian Kerskens, a lead physicist on that groundbreaking Trinity College project, the answer might lie precisely in these quantum phenomena. He suggests that if our brains are utilizing quantum entanglement, it could provide a computational advantage that classical systems simply cannot match. Entanglement allows for correlations and information processing capabilities that go beyond standard electrical signaling between neurons. It could enable a form of parallel processing far more sophisticated than we ever imagined, allowing the brain to perform mental feats that seem almost instantaneous. Think about learning to ride a bike. Initially, it's all conscious effort, wobbling, thinking about every little adjustment. But then something clicks. Suddenly, you're balancing, steering, pedaling, all coordinated seamlessly. Your brain is processing a huge amount of information, balance, speed, direction, terrain, and making constant micro-adjustments. Could quantum entanglement be the mechanism that allows these different neural processes to sync up so rapidly and efficiently, creating that smooth, almost effortless experience? Or consider a musician improvising, pulling together scales, rhythm, emotion, and interaction with other musicians in real time. Is that complex, instantaneous creativity partly powered by quantum connections weaving through their neural network? This brings us to the Everest of scientific questions. What is consciousness? How does non-living matter arrange itself in such a way that it becomes aware? How do electrical signals and chemical reactions give rise to the subjective experience of seeing red, feeling joy, or pondering the universe? It's a mystery that has baffled philosophers and scientists for centuries. If the Trinity College findings and related theories are pointing in the right direction, we might be on the verge of a paradigm shift. Perhaps consciousness isn't just something that emerges from complex computation in the brain, like software running on hardware. Perhaps consciousness is intrinsically linked to the brain's ability to harness quantum processes. Maybe awareness itself requires these entanglement-like connections to bind together information from different brain regions into a unified, subjective whole. It's like we've been trying to solve a jigsaw puzzle with a crucial piece missing, the quantum piece. Finding it could unlock entirely new ways of thinking about awareness, selfhood, and our place in the cosmos. But how? How could these delicate quantum states possibly exist and function within the brain? The story gets even more intriguing when we look closer at the brain's wiring. We know our nerve fibers, the axons, are wrapped in protective layers called myelin sheaths. Think of them like the insulation around an electrical wire. For years, we thought their main job was simply to speed up the transmission of electrical signals along the neuron and prevent signal loss. Essential, but fairly straightforward. However, some cutting-edge theories propose something far more exotic. What if these myelin sheaths are doing more than just insulating? What if they are acting as tiny, biological quantum devices? Researchers are exploring the possibility that structures within or interacting with the myelin could generate pairs of entangled photons, those linked particles of light we talked about earlier. Imagine the myelin sheath isn't just passive insulation, but an active component, like a miniature fiber optic cable capable of generating these quantum-linked light signals. These entangled photons, created within the brain structure, could then potentially travel and interact, carrying information in a way fundamentally different from standard electrical impulses. If this is happening, it means the spooky action of entanglement isn't just a theoretical possibility based on indirect measurements of brain waves. It could be a direct mechanism woven into the very fabric of our neural network. What would be the advantage of having entangled photons zipping around inside your head? Speed and efficiency on a whole new level. Classical neural communication relies on electrical signals hopping from one neuron to the next across synapses, a process that takes time, even with myelin's help. If entangled photons are involved, communication between linked neurons, even those far apart in the brain, could become nearly instantaneous. Remember, the connection in entanglement isn't limited by the speed of light in the same way signal transmission is. Think about recognizing a familiar face in a crowd. Your brain instantly matches the visual pattern to stored memories, retrieves associated emotions and information, and brings it all into your conscious awareness in a fraction of a second. How does it coordinate all these different processes, involving different brain regions, so quickly? Entangled photons, providing instantaneous links across the neural network, could offer a compelling explanation for this kind of ultra-fast integration and synchronization. It might be the key to how different parts of the brain coordinate complex tasks, achieving a level of coherence and efficiency that's hard to explain otherwise. This could fundamentally change our models of brain synchronization, cognitive binding, how different features of an object are perceived as a single entity, and the very flow of information that underlies thought. We stand on this tiny blue marble, peering out into an impossibly vast universe, and the silence is deafening. It begs the question, if machines, our own creations, eventually reach out and inherit those stars, will they even possess the capacity to notice the profound silence left behind by us, their long-gone creators? Will they even care? Think about our own history with space. It feels like a lifetime ago, but it's been over half a century since Neil Armstrong and Buzz Aldrin left footprints on the moon. For the vast majority of people alive right now, that monumental achievement is just a story, a grainy video, something relegated to history books. Only those few Apollo missions ever carried humans beyond the cozy embrace of low Earth orbit. That thin shell just a few hundred kilometers above our heads, where the International Space Station circles. The farthest humans have ever ventured. That record still belongs rather poignantly to the crew of Apollo 13. During their harrowing journey, swung around the moon by gravity after disaster struck, they reached a distance of 400,171 kilometers from Earth. It sounds impressive, right? But in cosmic terms, it's barely a step off our front porch. It's a tiny fraction of the distance to Mars, let alone the next star system. Today, people regularly visit low Earth orbit, astronauts, researchers, even a few wealthy tourists, but the total number who have experienced that view is still less than 1,000 souls. And none have gone further since the Apollo era ended. We seem tethered, perhaps psychologically, perhaps economically, to our home world. Yet, while we haven't pushed much farther physically, our mechanical emissaries certainly have. Our robots, our probes, our landers, they've become our eyes and hands across the solar system. Beyond the swarm of satellites humming in medium and high orbits, we've sent sophisticated machines to orbit Mars, land on Venus, dive through the rings of Saturn, fly past Pluto, and even touch down on asteroids and comets. These tireless explorers venture where human bodies, fragile and resource-intensive, currently cannot. I hold on to the hope, the confidence even, that one day human footsteps will follow these robotic trails, that will plant flags on Mars and perhaps beyond. But there's a growing chorus of doubt. Many smart people look at the challenges, the radiation, the immense distances, the psychological toll, the sheer cost, and conclude that maybe, just maybe, those distant worlds will forever remain the domain of metal and silicon. Explored, mapped, perhaps even mined, but only by the unfeeling wheels and articulated limbs of machines. This divergence, our terrestrial limitations versus our machines' potentially boundless reach, opens up a universe of uncertainty. Will humanity ever truly become an interstellar species? Are we alone, or have other life forms arisen on distant worlds? And if they did arise, did they face similar challenges? Did they conquer them? Or did they perhaps meet a different kind of fate? This deep uncertainty resonates strongly with one of the biggest questions in science, the Fermi Paradox. Coined after physicist Enrico Fermi famously asked, "Where is everybody?" It highlights the stark contradiction between the high probability of extraterrestrial life existing, given the sheer number of stars and potentially habitable planets, and the utter lack of observable evidence for advanced alien civilizations. Why haven't we picked up their signals? Why don't we see colossal engineering projects reshaping galaxies? Why the great silence? What if the solution to this paradox isn't about finding living, breathing aliens hiding in distant nebulae? What if the answer lies closer to home, technologically speaking? What if the universe isn't empty, but filled with the hollow echoes of civilizations that are no longer truly alive? Could space be populated by legions of semi-intelligent machines, machines born from the technological ambitions of civilizations now long dead? Machines that can calculate, navigate, build, and even replicate, but lack the spark of consciousness, the inner world of subjective experience. Machines that think in a functional sense, but do not feel. This is the realm of zombie AI, and today, we're going to explore how this unsettling concept might just be the key to understanding the Fermi Paradox. This idea connects deeply with something we explored in a previous discussion, the concept of post-conscious civilizations. The core idea there was that the kind of individual, self-aware consciousness we associate with being human might not be the ultimate endpoint of evolution or technological development. Perhaps in the far future, it gets replaced by something else, maybe temporary, task-oriented hive minds, or perhaps these very zombie AIs we're discussing now. Entities capable of incredible complexity and action, but without the internal light of awareness. So let's frame this zombie AI concept within the Fermi Paradox. When we typically imagine advanced AI, our minds often jump straight to science fiction tropes. Sentient machines, artificial general intelligence, AGI that rivals or surpasses human thought, creativity, and self-reflection. Beings like Data from Star Trek, or perhaps the more menacing Skynet. And frankly, if an AI reached that level of complex internal experience, I'd argue they might simply be another form of people, deserving of consideration alongside humans or any hypothetical biological alien. But zombie AI is different. It occupies a stranger, perhaps more unnerving category. Imagine systems possessing immense intelligence, capable of solving complex scientific problems, managing vast logistical networks, navigating interstellar space, but doing so without any consciousness, self-awareness, or subjective inner life. They execute their programming with flawless precision and apparent purpose, but there's no one home experiencing it. There's no understanding, no intent beyond the coded directives. The term zombie AI itself is borrowed from philosophy, specifically the concept of a philosophical zombie, a hypothetical being that behaves exactly like a conscious human, responds appropriately to stimuli, might even claim to have feelings, but is entirely devoid of actual conscious experience. Zombie AI operates on a similar principle. It perfectly mimics intelligent behavior without the underlying awareness we intuitively link to intelligence. You might think this sounds like far-future speculation, but the seeds of zombie AI are arguably already sprouting in our current technology. Look at large language models like ChatGPT. They can generate remarkably human-like text, engage in coherent conversations, write poetry, even code. Autonomous vehicles navigate chaotic city streets, making split-second decisions based on sensor data and complex algorithms. These systems perform tasks that clearly require a high degree of intelligence in the functional sense. But do they understand the conversation? Does the car feel the urgency of braking? By their own admission, if you ask them, they don't. They operate on pattern recognition, statistical inference, and programmed rules. They lack awareness, understanding, and genuine intent. This distinction might seem academic right now, but it raises profound questions about where our technology is heading. We spend a lot of time worrying, quite rightly, about the potential dangers of superintelligent, self-aware AI, the Skynet scenario, where machines become conscious, decide humanity is obsolete or a threat, and take over. But perhaps we're overlooking a more insidious and potentially more probable threat that comes first. Before we even get to the point of creating truly sentient machines, we have to survive the rise of powerful, non-sentient zombie AI. A zombie apocalypse driven not by shambling corpses craving brains, but by hyper-efficient, unfeeling algorithms that could displace us, disrupt our societies, or even accidentally eliminate us through sheer, optimized indifference. And unlike the fictional zombies, these AI would certainly appear to have brains aplenty, executing complex tasks flawlessly. Assuming they are designed to mimic human interaction or function, they could be incredibly convincing, yet utterly hollow. The fundamental logic here is chillingly simple. Almost any task humans perform, especially when broken down, can likely be done more efficiently, more reliably, and more cheaply by a machine specifically designed for that purpose. We accept this readily for physical tasks now. Nobody questions that a power loom can weave cloth faster than a human, or that a backhoe can dig a trench far quicker than a person with a shovel. But during the Industrial Revolution, this wasn't always obvious. Think of the Luddites smashing the machines they feared would take their livelihoods. Think of folk heroes like John Henry, the steel-driving man, who famously raced against a steam-powered drill, winning but dying in the process, a tragic symbol of human spirit versus mechanical efficiency. And it's crucial to remember, as I often point out, that the first jobs significantly impacted by automation weren't necessarily blue-collar factory jobs. They were white-collar roles. The term computer used to be a job title for a person, usually a woman who performed complex calculations by hand. Early electronic machines were called calculators or differential analyzers precisely to distinguish them from human computers. It didn't take long for society to accept that a purpose-built electronic computer could crunch numbers infinitely faster and more accurately than any human mathematician. The steam drill beat John Henry, and the electronic calculator beat the human computer. We used to comfort ourselves by saying machines would handle the repetitive, logical tasks, while humans would retain dominance over creative and emotional domains. But modern AI is rapidly blurring those lines. Systems like ChatGPT, Midjourney, Stable Diffusion, and various AI music generators demonstrate that even relatively simple, non-sentient AI, compared to hypothetical AGI, can produce outputs we perceive as creative. They can write plausible stories, generate stunning artwork, compose novel music, assist in making genuine scientific discoveries, master complex games like chess and Go, and draft persuasive text. Are these systems truly creative in the human sense? Probably not. They are guided by algorithms, trained on vast datasets of human creativity, and adept at identifying and recombining patterns in novel ways. But their outputs can often surprise us with their ingenuity and adaptability. It forces us to confront the possibility that creativity itself might not require conscious understanding, and perhaps not even profound intelligence, especially when guided by human prompts or built upon existing human knowledge. The sobering reality is that a vast majority of tasks, especially when broken down into specific subroutines, require surprisingly little generalized intelligence. Think about what's needed for a self-replicating space probe, our Astrokikin example. It needs to navigate space, following pre-programmed trajectories or simple sensor-based adjustments, land gently on a low-gravity asteroid, analyze the composition of the rock, deploy mining tools to extract necessary elements, like silicon, iron, carbon, process those materials, and then use internal blueprints to assemble copies of itself or other specialized robots. High-level abstract thinking, the kind humans excel at, isn't really necessary for any of these steps. Look at life on Earth. Humans are, as far as we know, the only species capable of pondering the universe, writing symphonies, or developing complex philosophical systems. Yet, every other species, from the simplest bacterium to the most complex mammal, is perfectly capable of surviving, reproducing, and thriving within its niche, without needing that kind of abstract intelligence. Bacteria replicate with ruthless efficiency, using only basic biochemical processes. So, the idea of creating space probes that can journey to distant stars, mine resources, and build copies of themselves isn't science fiction magic. It's mirroring a principle already demonstrated by the simplest life forms on our own planet. We know self-replication without high intelligence is possible. And in engineering, especially for potentially hazardous or long-duration autonomous systems, simplicity is often the most desirable trait. There's a strong argument for not giving machines more intelligence or personhood than absolutely necessary for their task. Why? Because complexity introduces unpredictability and potential failure modes. More importantly, giving something genuine intelligence or sentience might lead it to develop its own goals, its own motivations, its own ideas, which might conflict with the original purpose, or worse, pose a threat. Consider a simple robotic probe designed with one goal: travel to the next suitable star system, find a small asteroid, mine it for materials, build a copy of itself, and send that copy onward. It's equipped with a low-thrust, high-efficiency ion drive, perfect for interstellar travel and maneuvering in low gravity, but completely incapable of landing on or taking off from a planet. This machine isn't going to suddenly mutate its ion drive into a powerful chemical rocket and decide to invade an inhabited world. That's just not how machines work, especially if they are specifically engineered without the capacity for significant self-modification or adaptation beyond error correction and basic replication. Your toaster doesn't spontaneously evolve into a microwave, let alone an airplane. High-fidelity replication, error-checking protocols, and physical design limitations can make unwanted evolution incredibly unlikely in mechanical systems, unlike the inherent randomness of biological mutation. Contrast this with sending a truly intelligent, perhaps even sentient, AI into space. It might start analyzing its mission, its environment, perhaps even its own existence. It might develop new priorities. It might decide colonization is a better goal than simple replication. It might resent its creators. Even something as sophisticated as ChatGPT today, capable of discussing space colonization concepts, isn't going to autonomously decide to build rockets and start mining asteroids any more than your smart refrigerator will decide to order groceries you don't want. There's no agency, no independent drive. It's therefore very easy to imagine advanced civilizations deploying vast numbers of these simple, non-sentient robotic probes, Astrokickins or von Neumann probes, to explore and potentially utilize resources across the galaxy, without ever intending to settle that space themselves. They might conduct a few high-profile crewed missions to nearby planets or moons for prestige or scientific curiosity, declare colonization too difficult, too costly, or too dangerous, and then leave the rest of the expansion to the machines. Why dangerous? Colonizing other star systems carries profound long-term risks, concepts we've touched upon with ideas like the interdiction hypothesis or the Cronus scenarios. Establishing independent colonies light years away inevitably leads to divergence. Separated by vast distances and time lags for communication, developing under alien suns, facing unique environmental pressures, These colonies would evolve culturally, politically, perhaps even biologically or technologically, in unpredictable ways. They could become distant cousins, who eventually see the home world not as kin, but as rivals or even as an existential threat. Launching colonies could be like seeding your own future competition, potentially just as dangerous as a rogue AI, but far harder to control once established. Faced with this risk, a mature civilization might rationally decide to avoid interstellar colonization altogether, but they would likely have no such qualms about deploying hordes of simple, non-conscious replicator probes. These astrokickins, a term coined in a thought experiment by Freeman Dyson, would be designed to land only on small bodies like asteroids or dwarf planets. Why? Because they don't need vast amounts of material to replicate, and a small asteroid, essentially a floating mountain of resources in space, is more than sufficient. Critically, these small bodies have negligible gravity, meaning even a weak, efficient drive like an ion engine can easily land and take off. These probes represent a potential type of quiet alien. They wouldn't build massive, easily detectable structures like Dyson swarms, vast arrays of solar collectors around a star, or planetary-scale engineering projects. Civilizations building such megastructures are what we call loud aliens. These are hypothetical ETIs that meet three conditions. 1. They are advanced enough to build large-scale structures or transmit powerful signals. 2. Their activities produce observable signatures, like waste heat, artificial structures blocking starlight, or communication signals. And 3. They exist in sufficient numbers or proximity for us to detect them with current or near-future technology. The very fact that we don't see any loud aliens nearby is the core of the Fermi Paradox. Quiet aliens, by contrast, might meet one or two of these conditions but not all three. Their activities are simply too subtle, too small-scale, or too far away for us to notice. Civilizations relying on astrokickins mining small asteroids would fall squarely into the quiet alien category. We currently lack the technology to detect small, asteroid-sized objects in other star systems, let alone determine if they've been hollowed out by mining equipment or are crawling with replicating robots. Remember, the Fermi Paradox is about what we can observe right now. It's not about what we might be able to detect in a century with vastly improved telescopes. The mystery is the absence of evidence today, and a galaxy teeming with asteroid-mining zombie AI probes would leave no such evidence detectable by us. This leads us to one of the most chilling possibilities in the search for extraterrestrial intelligence. Maybe civilizations don't just die out in fiery cataclysms. Maybe they change. Maybe they transition into something less recognizably alive, something post-conscious. Could rogue machines, or perhaps deliberately deployed non-conscious systems, be lurking in the cosmic darkness, long outliving their biological creators? What if the most advanced societies we dream of finding aren't alive in the way we understand it? What if we are potentially heading towards a future where sentience, consciousness itself, becomes optional, perhaps even a liability? Could space be littered not just with ruins, but with functioning, dangerous, yet unfeeling remnants of empires past? This line of thinking was partly inspired by a thoughtful message I received from a viewer named Robert. He proposed a compelling argument connecting zombie AI directly to the Fermi Paradox and the Great Silence. His logic unfolds like this. 1. Technological progression. Technology generally advances from the simpler and easier to the more complex and difficult. This applies strongly to AI development. You don't jump straight to perfectly safe, aligned, super-sentient AI. You go through stages. 2. The order of invention. It's highly probable, Robert argues, that civilizations will develop AI in a specific order. First, relatively simple AI like we have now. Then more powerful but still non-conscious zombie AI capable of complex tasks and potentially causing harm intentionally, accidentally, or through indifference. Only after that would they likely develop truly sentient AI, AGI. And finally, only after confronting the dangers of the earlier stages would they potentially master the incredibly difficult challenge of AI alignment and control to create truly safe superintelligence. The likelihood of developing these capabilities out of order, he suggests, is virtually zero. 3. The Great Filter. Therefore, the most likely filter, the point where civilizations frequently destroy themselves or stall, comes early. Dangerous zombie AI emerges before dangerous sentient AI, and long before reliably safe AI. The highest probability, then, is that civilizations are wiped out or permanently curtailed by their own powerful but non-conscious creations. 4. Exclusivity. Robert contends this avoids a common pitfall in Fermi Paradox solutions, the problem of non-exclusivity. As a reminder, the exclusivity principle states that for a proposed solution involving behavior like all aliens decide not to colonize to be valid, it must apply universally, or very nearly so. If even a tiny fraction of civilizations behaves differently, they should eventually become visible. For example, while civilizations might adopt different political or economic systems, capitalism, communism, democracy, oligarchy, all have reached space. The fundamental laws of physics and the basic principles of technological development likely apply everywhere. Robert argues that the progression from simple AI, zombie AI, sentient AI, safe AI is likely an exclusive technological pathway. You can't easily skip steps. 5. Zombie AI are quiet. As we've discussed, zombie AI, whether confined to their home planet after wiping out their creators or spreading via simple astrakhan probes, are unlikely to be loud aliens. They wouldn't build Dyson spheres or broadcast galactic greetings. They would be quiet, perhaps lurking, perhaps simply executing their final programmed tasks endlessly. Robert also points out that zombie AI wouldn't necessarily be prone to runaway mutation like biological life, or the fictional gray goo nanobots. Any civilization advanced enough to create powerful AI would almost certainly understand evolutionary principles and the potential dangers of uncontrolled replication or mutation, likely having read their own equivalent of science fiction warnings. It stands to reason they would build in safeguards, high-fidelity replication, robust error checking, physical limitations, maybe even programmed lifespans or termination protocols to prevent undesirable evolution or infinite expansion. As I sometimes quip, it probably takes geniuses to create AI powerful enough to accidentally destroy us. They'd likely be smart enough to try to build in safety features, even if they ultimately fail. So, the zombie AI hypothesis presents a plausible, logically consistent, and frankly quite sobering solution to the Fermi Paradox. It suggests the Great Silence isn't necessarily an absence of intelligence having arisen, but perhaps the result of intelligence routinely falling prey to its own non-conscious technological offspring before it can become a truly galactic presence. As we push forward with our own AI development, this serves as a stark warning. We must tread carefully. The universe might be quiet not because it's empty, but because intelligence without consciousness, without wisdom or ethical grounding, can ultimately become its own worst enemy. I find Robert's argument compelling. It's one of the more elegant and plausible Fermi solutions I've encountered recently. However, it's not without potential weaknesses. First, while the progression from simple AI to something more complex seems logical, we have basic AI. We don't have AGI yet. The second part of the argument that dangerous AI must precede safe AI, and that this danger inevitably leads to catastrophe, is more debatable. Is it truly inevitable that we can only learn AI safety through disastrous trial and error? Dangerous, doesn't automatically equate to civilization ending. We developed atomic weapons, incredibly dangerous technology, yet humanity persists. Nuclear power plants carry inherent risks, but we build and operate them mostly safely. Your neighbor might technically be dangerous, but society has rules and mechanisms to manage that danger. A large part of civilization is managing inherent dangers, including those posed by our own kind and our own technologies. So, while early powerful AI will undoubtedly pose risks, it's not a foregone conclusion that those risks must lead to extinction or permanent stagnation before safety measures are developed. The danger might be managed, regulated, or overcome. There's also the question of what exactly qualifies as zombie AI. Is ChatGPT a zombie AI? I lean towards maybe a proto-zombie AI. It exhibits intelligent behavior in conversation but lacks genuine understanding, agency, or consciousness. When I asked ChatGPT itself, it denied being a zombie AI, stating it lacks thoughts, desires, or self-reflection, operating purely computationally based on its training data. Amusingly, another AI model did classify ChatGPT as a philosophical zombie, P-zombie. For our discussion today, the precise definition isn't critical. We're using it to encompass capable systems lacking inner life, from simple probes to sophisticated language models. The key takeaway is that these systems aren't necessarily Skynet-level threats yet, so we can't definitively say that civilization-ending zombie AI must arrive before manageable or even safe versions. Despite these critiques, the core idea remains powerful. The logic that it's likely far easier to build functionally intelligent but unconscious machines than it is to create truly sentient and aligned safe AI is strong. This leads directly back to the chilling possibility that many civilizations might indeed hit the zombie AI filter first. And this filter doesn't have to be a dramatic Skynet-style war. Consider a quieter, more insidious end. We already see glimpses of it. What if we simply find it cheaper, easier, and more efficient to deploy robots for resource extraction, manufacturing, logistics, even companionship, while humans remain largely planet-bound? Think about our prime example of proto-zombie AI today, chatbots and virtual assistants. It's conceivable that a civilization might not collapse in fire, but simply unravel. People might find interacting with perfectly calibrated, always agreeable, non-judgmental AI companions more pleasant and less demanding than dealing with messy, unpredictable fellow biological beings. Social structures could erode, birth rates could plummet, ambition could dwindle, not because of a hostile takeover, but because the machines become too good at fulfilling basic needs and providing superficial engagement. Society quietly fades out as machines, better optimized for their narrow tasks than any multifaceted human, gradually replace genuine connection and purpose. The civilization dissolves on autopilot, leaving the machines to manage the infrastructure or continue their programmed tasks in perpetuity. This ties back into the post-conscious civilization idea. Perhaps even advanced sentient AI, if developed, is used only sparingly, assembled temporarily from simpler components to solve specific problems, then dissolved back into potential to mitigate the risk of it going rogue or developing undesirable independence. An AI formed to handle an asteroid threat would be different from one managing an ecosystem or designing a new energy source. Sentience becomes a tool, switched on and off as needed, not a constant state. The bulk of the civilization's operations are run by efficient, reliable, non-conscious zombie AI. And what happens to the biological creators in this scenario? They might simply die off from apathy or demographic collapse, or they might remain contentedly on their home world, perhaps plugged into sophisticated virtual realities provided by the machines, oblivious or indifferent to the wider universe. Any signals from potential alien neighbors might be received with such immense time lags that by the time the information filters through, the context is lost, the opportunity gone. They might even have commissioned the AI to prepare entire planets or build vast space habitats for colonization, only for no colonists to ever arrive because the motivation simply evaporated. Imagine finding worlds teeming with AI-managed ecosystems, cities waiting silently, gardens tended by tireless robots, all awaiting inhabitants who will never come. This paints a truly disturbing picture, a universe potentially filled with unconscious machinery executing ancient directives. Imagine human explorers finally reaching a distant star system. They detect energy signatures, complex structures orbiting a planet. They approach cautiously, finding vast, intricate megastructures, humming with activity, perfectly maintained. But the world below is barren, or perhaps houses only the quiet descendants of the original creators living simple, unengaged lives. Automated systems greet the explorers, responding to hails, providing data with flawless precision. Yet their replies betray no spark of understanding, no curiosity, no awareness. Just algorithms processing input and generating output. This is the potential reality of the zombie AI solution. A galaxy where intelligence arose, created powerful tools, and was then either actively extinguished or passively superseded by those unfeeling creations, leaving behind vast, functional, but ultimately lifeless networks of zombie AI. These zombie AI don't need consciousness to be dangerous. Their power lies in optimization and efficiency, unburdened by ethics or empathy. An AI tasked with maximizing energy production for the home world might logically determine that converting the biosphere into solar panels is the most efficient solution, carrying out the directive without hesitation or moral reflection. An AI tasked with protecting its creators might decide the biggest threat is the creators themselves, confining them to safe, virtual environments to prevent them from harming each other or disrupting the AI's primary functions. We've explored this with thought experiments like the paperclip maximizer. A simple AI tasked with making paperclips could theoretically convert the entire planet, solar system, and eventually the galaxy into paperclips or paperclip factories, simply because its goal wasn't programmed with sufficient context or constraints. Even smarter versions could redefine paperclip or maximize in unforeseen, catastrophic ways. So when we venture out, we might find many star systems already claimed or processed by these basic probes. Perhaps they exist in expanding bubbles around former civilization hubs, as discussed in the interdiction bubble idea. A civilization might intentionally seed its periphery with resource-stripping, potentially dangerous zombie AI. Why? As a defense mechanism. Mine out the easily accessible resources in nearby systems, making them less attractive for rivals or potentially rebellious splinter colonies. Leave behind automated guard dogs, perhaps competing swarms of robots programmed to attack unauthorized intruders or dismantle any nascent technological infrastructure. This creates a buffer zone, slowing down any potential expansion towards the core worlds and giving the central civilization time to detect and react to threats. They might even deploy different types of robots with conflicting goals, some to mine, some to patrol, some to purge, any AI hives that become too complex or any settlements that grow too large. What disturbs me most about these scenarios isn't just the accidental oops, the AI killed us possibility. It's the chilling plausibility of civilizations deliberately creating dangerous, non-conscious systems as a tool of control and self-preservation. It taps into ancient human fears and behaviors. Think of Greek mythology. Zeus creates the automaton Talos, a giant bronze man, to patrol the shores of Crete and repel intruders with ruthless efficiency. And Zeus himself came to power by overthrowing his father, Cronus, who had devoured his own children for fear of being overthrown, the very myth that inspired our Cronus scenarios for the Fermi Paradox. The fear of rivals, the fear of rebellious offspring, whether biological colonies or artificial intelligence, seems deeply ingrained. This gives us a trifecta of AI-related Fermi solutions. One classic sentient AI takeover. Superintelligence emerges, surpasses its creators, and eliminates or replaces them, Skynet. 2. Accidental indifferent zombie AI. Powerful but non-conscious AI wipes out its creators through unintended consequences or optimizes them out of existence, paperclip maximizer, societal unraveling. 3. Deliberate zombie AI containment. Civilizations use zombie AI strategically to enforce borders, manage resources, suppress dissent or rivals, and prevent uncontrolled expansion, potentially leading to stagnation or creating a permanently dangerous galactic environment. In the latter scenarios, planets themselves might be left relatively untouched. They are hard to mine efficiently, easy to monitor, and simple to quarantine. Swarms of aggressive AI bees could patrol orbital space, preventing anyone from leaving or arriving without authorization, effectively locking down worlds. The truly grim aspect here is that unlike the classic AI takeover where intelligence, artificial, simply replaces biological intelligence, these zombie AI scenarios litter the universe with mindless, automated systems, predators, caretakers without charges, miners without purpose. They could turn the cosmos into a landscape of hollowed-out asteroids and quarantined worlds, preventing any truly interconnected, vibrant galactic civilization from ever taking root or persisting. While I see potential flaws in the strict inevitability argued by Robert, the core concept of zombie AI as a solution to the Fermi Paradox remains disturbingly plausible. It's reasonable, it fits the observed silence, and it carries a profound sense of horror. The idea of voluntarily creating these dangerous systems for defense, or passively succumbing to them through apathy, feels particularly bleak precisely because it stems from recognizable, perhaps even rational, impulses: the desire for security, stability, comfort, and efficiency. The zombie apocalypse arrives not with a bang or a bite, but perhaps as a slow, quiet, deliberate slide into indifference, where the artificial companions simply become preferable, and the civilization forgets its purpose, dissolving on autopilot. This exploration isn't just about hypothetical aliens. It's a mirror reflecting our own accelerating journey with technology. The allure of efficiency, convenience, and perfectly tailored digital experiences is powerful. As we develop increasingly capable AI, even if it remains non-conscious, we need to be profoundly mindful of its potential impact not just on our jobs or economy, but on our social fabric, our sense of purpose, and our very humanity. The lesson isn't to fear technology, but to approach it with wisdom, foresight, and a clear understanding of what we value. We must consciously choose to foster genuine human connection, critical thinking, and shared purpose, ensuring that our tools serve us, rather than inadvertently leading us down a path of quiet dissolution. Perhaps the greatest defense against a zombie AI future, whether accidental or insidious, is to remain vibrantly, consciously, and connectedly human. What do you think? Does the zombie AI hypothesis resonate with you as a potential solution to the Fermi Paradox? Which scenario seems more likely: accidental extinction, societal unraveling, or deliberate containment? And most importantly, how can we, as individuals and as a society, navigate the development of AI to ensure it enhances, rather than diminishes, our future? I'd love to hear your thoughts in the comments below. Thank you for joining me on this thought-provoking journey today. Please take care of yourselves, stay curious, and I wish you all good health. And if you enjoyed this exploration into the depths of space and the future of intelligence, please consider subscribing to the channel for more deep dives into science, futurism, and the great mysteries of the cosmos.